Hello everybody and welcome to your maths lesson for today. We're going to start today's lesson by revising fact families. You did this in yesterday's lesson when you made your array cities. Can you remember what a fact family is? That's right, a fact family is a set of number sentences which are related to each other. That means we can use the same numbers to make divide sentences and times sentences. We can also use them for add and take away, but today we're going to be using them for dividing and timesing. Okay, let's start. So we've got our first fact family triangle. So you can see normally we would have three numbers. At the moment we've only got two. How do we find that top number? Remember, the top number is the whole, it's the biggest number. So how are we going to get to that? We need to do this and this one to get to this one. Is it going to be times or divide? That's right, it's going to be times. For our number to get bigger, we need to times it to get more groups. If we divide it, we're sharing it out, so we'll get smaller. So 2 times 8, put two fingers up, count in 8, 8, 16. It's the same as 16. So 16 is our whole. So we've already got our first number sentence. 2 times 8 is the same as 16. What other number sentence could we write? Remember, for multiplication, we can switch the numbers around and we'll get the same answer. So we've done 2 times 8 is the same as 16. Let's go the other way. Ready? 8 times 2 is the same as 16. So we've got our two times sentences. We now need our two division operations. So what number are we going to start with for divide? That's right, we need to start with 16. We need to start with our biggest number. If we can't do 8 shared between 16 because 8 is smaller. So if we shared that out, we wouldn't get a whole number. So our biggest one is 16. So we can share 16 between 8. 16 divided by 8 is the same as 2. Let's go the other way. Start with 16 again. Start with our whole. 16 divided by 2 is the same as 8. Fantastic. Let's have a go at the second one. Pause the video. Can you have a go at finding what your whole is? And then write 4 number sentences to describe this fact family triangle. Once you're done, unpause the video and we'll go through it together. Pause and do that now. Ready to go through it? So just like this one, I have my 2 bottom numbers. The 2 bottom numbers are the smallest numbers, so I need to times them to get to my whole, my biggest number at the top. So you could have had 7 times 3 is the same as. How do we do that one? Some of you might just know it. Otherwise, use the finger method. Ready? 7 fingers up, count in threes. 3, 6, 9, 12, 15, 18, 21. Now I've got 1 times by sentence. I can now find the other one. Did you go the other way to get 3 times 7 is the same as 21? Now it's trickier. We used to do our division one. Division always start with the biggest number, 21, divided by 7 is the same as 3. Or go the other way, 21 divided by 3 is the same as 7. Got it? Well done. This one looks a bit different. Well, how does this one look different? In the first two, we had the bottom 2 numbers, but not the top number. In this one, what have we got? That's right, we've got the whole, the top number, one of the bottom numbers, but this one is missing. How are we going to get that one? What do we have to do? Can we do a time sentence? No, we can't do a time sentence as we haven't got a number here. So we have to do a divide. So start with biggest number, 36, divided by 4. Now, we had lots of methods of doing this division. We had sharing circles, we had arrays, but we worked out that took us a very long time when we had to share out a big number. So what can we do? That's right, we can do the opposite. So we know 4 and we know 36. If we switch it around, we can do 4 times something. 4 times something is the same as 36. I don't know what this is. So I can count in 4s, because I know that one, because we know that multiplication can go any way around. So at the moment, I know my 4. I don't know what it's timesing, but I know it's 36. So I don't know what goes in there. So I can do something times 4 is the same as 36, which means I can now count in 4s. Ready? 4, 8, 12, 16, all the way to 36, 20, 24, 28, 32, 36. So I counted 9 4s. Okay, now I've got it. So I know 36 divided by 4 is the same as 9. Let's go the other way. 36 divided by 9 is the same as 4. And now I've got my bottom 2, I can do my times. 9 times 4. Number must be getting bigger because I'm multiplying. Same as 36. Now go the other way. Did you get all of those? This is how I feel if you've understood and you've got all of those. Fantastic job. Today we're going to still be looking at multiplication, but we're going to be multiplying larger numbers. To do this, we need to use what we call related maths facts. So if we know how to solve one operation, how can we use it to solve another? So we're going to be using the times tables we know to solve multiplication using bigger numbers. Ready? I think you can do it today. It's going to be challenging, but we're going to have a go. The first thing we're going to do is we're going to think back to when we were counting in 20s. When we were counting in 20s, we found out we could use our 2 times table to help us with that. Don't worry if you don't remember, it was a very long time ago, so we're going to revise it. The first thing we're going to do is count in 2s, which is in my top row. As I put down the Deans, I would like you to say the numbers. The first one we've got is 2, then 4, then 6, good job, then 8, then 10, fantastic, then 12, you're doing really well, then 14. Let's say our 2 times table, counting in 2s to help us. Ready? 2, 4, 6, 8, 10, 12, 14. Now, counting in 20s is trickier because it's a bigger number. So I'm going to use my Deans to help me, and then we're going to work out the pattern again. So if I'm counting in 20s, I need 2 10s. 10, 20. Okay, now I need another 2 10s. I'm now on 10, 20, 30, 40. Again, another 2 10s. I've now got 10, 20, 30, 40, 50, 60. Do you notice what the pattern is? 1 times 2 is 2. 1 times 20 is 20. 2 times 2 is 4. 2 times 20 is 40. 3 times 2 is 6. 3 times 20 is 60. Can you see what's happening? 2 and 20, 4 and 40, 6 and 60. What's happening? When I'm counting in my 20s, I've got a 2 like here, I've got a 4 like when I'm counting in 2s, and I've got a 6 like here. What's the difference though? That's right, here I've got 2 10s, but here I've got 2 1s. Here I've got 4 1s, but here I've got 4 10s. Here I've got 6 1s, but here I've got 6 10s. And that's why I have the 0 on the end. I have 2 10s, but no 1s. 4 10s, but no 1s. 6 10s, but no 1s. So it's just the same, but I'm timesing it by 10. If I have 2 1s, when I times it by 10, it gets, do you remember that action? 10 times bigger. So they're going to be turned into 10. So I have 2 10s, which makes 10 20. When I have 4, it's going to get 10 times bigger and become 4 10s, which makes 10, 20, 30, 40. When I have 6 1s, but I want to turn it into 6 10s, ready? 10 times bigger. It becomes 6 10s, which is 10, 20, 30, 40, 50, 60. That's much easier. If I know this 2 times table, I can just times it by 10. What's going to be the next number in my pattern? So 8, if I make it 10 times bigger, so I haven't got 8 ones, I've got 8 tens, what's it going to be? That's right, it's going to be 80. 8 tens, no ones. What about the next one? 2, 4, 6, 8, 10. If I'm counting in 20s, it's got to get 10 times bigger, so I've got 10 tens this time. When I've got 10 tens, what does that make? Do you remember? Let's have a look. Let's have a look. 1 10, 2 tens, 3 tens, 4 tens, 5 tens, 6 tens, 7 tens, 8 tens, 9 tens, 10 tens. And we know this makes 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's going to change to 100. Then what happens when I get to 12? What's my next one in my 20 pattern? 20, 40, 60, 80, 100. My 12 has to get 10 times bigger. So it's going to become 120. Good job. Need to get more tens out. It's becoming a huge number. I'm actually at this point going to show us our place value chart. 'Cause if we have 12, the number 12, like this, so that's in our 2 pattern, 2, 4, 6, 8, 10, 12. And I know when I want to do it in my 20 pattern, I have to make it 10 times bigger because 20 is 10 times bigger than 2. I'm going to have to make all of this 10 times bigger to make it in my 20 pattern. So what happens? Instead of this one is going to move into this one because I'm going to have 10 tens now. This changes to this. And my 2 ones, when I move them over, because when I move them over, I'm just timesing it by 10. What are those 2 going to become? Because the 10s don't want 2 ones in there. They're going to say, get out. They change into 2 tens. That's right. So now I've got 100, switch, 110, 120. And that's all that's happening in here. So my 10 from the 12 gets 10 times bigger and becomes 100. And my 2 ones turn into 2 tens to make 20, 120. What about 14? How is that going to become 10 times bigger? Let's have a look at my chart again. So I have 14. Let's make 14 on here. 10, switch, 11, 12, 13, 14. To times by 20, I need to make it 10 times bigger because I'm counting in tens now, 2 tens in 20. So it's 10 times bigger. What happens? So 10 is going to become 10 tens. So it's going to move over here and it's going to become a 100. And the 4 ones, are going to get 10 times bigger and become 10, 20, 30, 40. So when I times by 10, everyone just moves into the next column. So this one's going to be 100, switch, 110, 120, 130, 140. Do you see how you can use the 2 times table to help us with our 20 times table? We're using related maths facts. We're using 2s to help us with 20s. Let's see if we can do a similar thing with counting in 50s. So for counting in 50s, I can use this pattern. Can you spot what pattern it is? Let's count it together first. Ready? 5, 10, 15, 20, 25, 30. What am I jumping in each time? From 5, 6, 7, 8, 9, 10. That's a jump of 5. After 10, 11, 12, 13, 14, 15. That's a jump of 5. So it's my 5 times table. I'm counting in 5s. Ready to do that together? Ready? 5. Well, I'm going to have to get a lot of 1s this time. 10. You might have to be very patient with me whilst I get all of these Deans out. 15. 'You hear me rummaging around in my bag? 20. After 20, I've got 25. And after 25, I've got 30. Good job. So I'm just going to arrange these so they're a little bit neater. Whoops. There we go. I've got my groups of 5. Let's practice counting them again. 5, 10, 15, 20, 25, 30. Now, if I want to count in 50s, and we know my first one's going to be 50, what do you notice has happened? Here we have 5 1s. Here we have 5 10s. So it's got 10 times bigger. This one has turned into a 10. This one has turned into a 10. This one has turned into a 10. And the other 2 have turned into 10s. So it's got 10 times bigger. This has turned into a 10. This one, this one, this one, and this one. So 50 is 10 times bigger than 5. And if we counted in 5 to 50, we'd do it 10 times. Ready? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 10 times bigger. So what happens here when I get 10 times bigger? I've got 1 10. If that gets 10 times bigger, it's going to turn into, that's right, a 100. 15. 5, 10, 15. What happens to 15 when it gets 10 times bigger? Should we have a look at this again? I've got my 10, 11, 12, 13, 14, 15. When it gets 10 times bigger, the 10 becomes a 100. Let's put this on the top. It's got 10 times bigger, and the 5 1s become 5 10s. Good job. So my next number will be 100 switch, 110, 120, 130, 140, 150. Okay, let's try and do it this time without the Deans. So 20, that means if I have 2 10s, 10, 20, and they get 10 times bigger, they're going to become, this 10 times 10 is 100, and this one 10 times bigger, another 100. So it becomes 200. What about 25? So we know that 20 becomes 200. What happens to my 5 1s? They turn into 5 10s, which makes 250. And the last one, 30, which is 3 10s, if they get 10 times bigger, they all turn into hundreds. That's right, so we'd have 300. Can you see what's the same? That's right, so they just get 10 times bigger. And you've got a 0 on the end because they've all moved across a column. So when you have 5, it moves across to become 5 10s and no 1s. Can you see that? Let's try it with the next one. If you have 10 here, a 1 and a 0 in the 1s, this moves across to become 100. You have no 10s and no 1s. Let's try one more. Let's try 25. So if you have 25, the 2 tens are going to move across to become 200. The 5's going to move across to become 5 tens, which is 50. And we've got no 1s. That's why you have a 0 on the end when you times by 10, because it's moving across to the next place value column. You're doing really well so far. I'm super impressed. Did you remember how to times by 20 and by 50? We did that right at the beginning of the year. Okay, let's do our next step. What do you notice about the following pattern? So the number sentences say 2 times 4 is the same as 8. And this one says 2 times 40 is the same as 80. What's the same? That's right, we've got 8 here and 8 here, except this would mean 8 ones because we've got 2 times 4 ones. So we've got 1, 2, 3, 4, 2, 3, 4. 2 times 4 ones. 2 lines of 4 ones is the same as 8. What happens here? Does it mean the same? Why not? Because here we've got 2 groups of 40. So that's 10, 20, 30, 40. 10, 20, 30, 40. We've got 2 groups of 40. So the 2 and the 4 are the same here, and the 2 and the 4 are the same here. But here this means 2 times 4 ones is 8 ones, and here 2 times 4 tens is 8 tens. So they do look a little bit similar. We can use our 2 times 4 to help with 2 times 40. Let's go back to our place value chart to help us with that. So we had 2 times 4. So I'm going to draw in my place value chart again. So we had 2 times 4, which was the same as 8. We know that already. Put 2 fingers up. 4, 8. So when we do 2 times 40, we just know we have to make it 10 times bigger. So what happens? That's right, this moves into the tens column. So our 8 ones become 10 times bigger and turn into our tens. Count them to check. 10, 20, 30, 40, 50, 60, 70, 80. Got it? Do you see how we can use that? If we know 2 times 4, we then know 2 times 40 because we can make it 10 times bigger. 2 times 4 is the same as 8, and then we just times it by 10 to get to 80. And you can see that here. 2 times 4, it's got 10 times bigger, and that's why we've got 4 tens in each group. Let's have another practice. Let's do it with this one. So let's try. 3 times 3. What is 3 times 3? 3 fingers up. 3, 6, 9. And if you're not sure, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1 group of 3, 2 groups of 3, 3 groups of 3. Okay, what does that look like for 3 times 30? 10, 20, 30, 10, 20, 30, 10, 20, 30. 1 group of 30, 2 groups of 30, 3 groups of 30. Now we know 3 times 3 ones is 9. This one looks similar, but it's 3 times 3 tens. How can we use this to help us? If you want to, you could draw out your place value chart to help you. So I know 3 times 3 is 9. Ready? 1, 2, doing it as a drawing this time. 3, 4, 5, 6, 7, 8, 9. But I need to make it 10 times bigger because they aren't 3 ones that I'm timesing by. I'm timesing 3 tens. So to times by 10, they all move over and they become tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. So now I've got 9 tens and no ones when I times it by 10. There we go. And I can even check 10, 20, 30, 40, 50, 60, 70, 80, 90. So the secret is, I like to call it my find the secret times table. So if I'm doing 3 times 30, I find my secret times table, and that's 3 times 3. That's the times table I know. I work it out, so I know 3 times 3 is the same as 9. And then I just make it 10 times bigger. So I know my answer is going to be 9 at the beginning and times it by 10. So I move it over to get 9 tens and 0 ones. We're going to practice this lots though, as I know it's a new concept. Ready? Let's use our secret facts to help us. Let's read this one out. What does it say? 3 times 20. So that's harder to count in our heads. What is the secret times table that we know? Ready? Secret times table. Can you say it? Secret times table. My secret one is 3 times 2. I know that one. So 3 times 2 is the same as 3 fingers up, counting 2s. 2, 4, 6. But I'm not timesing by 2. I'm timesing by 20. So it gets 10 times bigger. Because it's not timesing by 2, it's timesing by 20. And I know this is 10 times bigger than this. This one's been turned into a 10. This one's been turned into a 10. So what do I need to do next? That's right. I just need to do that answer times by 10, which is 6 times 10. It's going to be a 6. 6 tens and 0 ones. If you want to, you can use a place value chart to help you with that. So if I know 3 times 2, which is 6, I just make it 10 times bigger. So it goes 10, 20, 30, 40, 50, 60. So that's my answer there. Some of you might be able to write out the secret times table and then times that by 10. Let's have another practice. Ready? Okay, this time we're going to do six times 40. If you're confident, have a go. Find the secret times table first. So what's our secret times table? Our secret times table is 6 times 4. 6 times 4, 6 fingers up, ready? 4, 8, 12, 16, 20, 24. Now, I'm not timesing by 4 ones, I'm timesing by 4 tens. So this has to get 10 times bigger. So I do 24 times 10. Do you remember what happens? So this is 24. 2 tens, 4 ones. What happens? That's right. This becomes hundreds. Because if I times this by 10, they each become 100. Do you remember I have 10 tens in 100? The 4 ones become 4 tens. And now I have 0 ones. You must put the 0 here as a placeholder. If you don't, it will look like 24. So my answer is 240. Oh my goodness. We're getting really good at this now. Let's try one more. It's going to be a big one. It's going to be in our 8 times table this time. We're going to try 7 times 80. Pause the video. The first thing you need to do is write your secret times table and solve it. Then you times it by 10. If you need to, use your place value chart. Pause the video and have a go at that now. Ready? What's the secret times table? That's right, the secret one is 7 times 8. 7 fingers up. 8, 16, 24, 32, 40, 48 then, 56. But I'm not timesing by 8 ones. I'm timesing by 8 tens. So it has to get 10 times bigger. 56 times 10. Do we know what that is? Remember, if you're unsure, draw out your place value chart, hundreds, tens, ones, and write 56 in it. What happens? 5 tens turn into 5 hundreds, 6 ones turn into 6 tens, and 0 as our placeholder. Answer is 560. How are you finding this? Shall we do one more? Okay, let's do one more. This is a long video, guys, but you're doing really well. We're going to crack this together. This time I'm going to do we might use my 3 times table. Let's see. So my number sentence is 9 times 30. Pause the video. Have a go. Secret times table, then times by 10. Ready? What's my secret times table? 9 times 3. Put 9 fingers up, count in threes. 3, 6, 9, 12, 15, 18, 21, 24, 27. But I'm not timesing by 3 ones, I'm timesing by 3 tens. So everything has to get 10 times bigger. 27 times 10. What's my answer going to be? Ready? 27, 2 tens become 2 hundreds, 7 ones become 7 tens, and I've got no ones, 270. Okay, on your portfolio, you've got lots of number sentences like these. To solve them, you need to write your secret times table and then times that by 10. Have a go at doing that now. Well done for persevering with this. It's tricky, but I'm really proud of you. Bye for now.